All right, Honors Algebra 2, this is our start of Chapter 13. And we're just going to be doing 13.1, Part A. So we're just going to be doing the front side of the notes today. And we're going to be talking about trigonometric identities today. All right, so we have these three basic trig identities that we're going to talk about, and these are all very important. And the reciprocal ones, I believe you know already, but let me just go over them pretty quickly. All right, so the cosecant is the reciprocal of the sine function. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So hopefully you guys knew that already, and if not, now you know. All right, and then we have our quotient identities, and this is specifically for tangent and cotangent. All right, so then for tangent, we have it's equal to sine over cosine, and since cotangent is the reciprocal of tangent, it makes sense that cotangent would be cosine over sine. Now let me show you kind of a little quick I guess, proof of why that is for the tangent one. So we know, if we remember, our SOHCAHTOA sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. All right, and so if we simplify that, the hypotenuse cancels out, giving us opposite over adjacent, which we know is tangent. So that's just kind of a quick reasoning of why that is. All right, now for this lesson, I actually want to focus a lot on these Pythagorean identities. So these, I believe, are brand new for you guys. All right, and our Pythagorean identities, there's three of them. The first one is that sine square theta plus cosine square theta is equal to 1. All right, so notice that it's the sine function that's being squared, not the theta, and that's why we put the square inside, and same thing with cosine. So that just means sine, oops, let me switch that. This just means sine of theta square plus cosine of theta square is equal to 1. All right, so that's what that notation means. We also have one for tangent and secant. All right, so then this is tangent square plus 1 is equal to secant square. And then our last Pythagorean identity right here is 1 plus cotangent square theta is equal to cosecant square theta. All right, now it might seem like a lot to remember, so what I want you guys to do is think, actually you really only need to know one, and you can derive the other ones from the first one. So let's just go ahead and focus on this first one, okay? And so, excuse me, if we know that sine square theta plus cosine square theta is equal to 1, I can actually easily derive the second Pythagorean identity from this by dividing everything by cosine square theta. All right, so let me go ahead and divide everything by cosine, oops, square theta. And if you see this right here is going to give me tangent. This is going to give me 1. And the last one is going to give me secant square. All right, so you can see how that quickly derives to our second Pythagorean identity. And you could do the same thing for our third one. So let me show you that one real quick. And so if I wanted to, let's say I just, forgot, I don't exactly remember which trig function is in this Pythagorean identity, I can go off the first one. And if I divide everything by sine square theta, that gets me 1. This is cotangent using that quotient identity, and this is cosecant. And that gives you this one right here. All right, so you can feel free to memorize all 3, but just know that if you just know the first one, you can derive the other 2 pretty quickly. All right, so let's go ahead and get into an example here. All right, so we have number 1, find the exact value of each expression, and they tell you that theta is equal or is in between 0 and 90 degrees. All right, and that's going to be a huge help because this tells me that this is in quadrant 1. And knowing that is going to be helpful a little bit later on. All right, so number 1, it says, if tangent of theta is equal to 4/3, find cosine of theta. All right, now I'm going to go ahead and look at my Pythagorean identities, and I want to see what involves tangent and cosine. All right, so if you look at the second identity, the second Pythagorean identity has tangent and secant is just the reciprocal of cosine, so that's the one I'm going to use. So I'm going to use that tangent square theta plus 1 is equal to secant square theta. And I'm going to plug in 4/3 for tangent, and I'm going to square it, plus 1 is equal to secant square theta. All right, so that gets me 16/9 plus 1, which is 25/9. And I'm going to square root both sides. All right, and remember this gets me plus or minus. So I'm going to flip this around. So secant of theta is equal to plus or minus 5/3. Okay, which means if I want to go to cosine, I'm going to move this up here. Cosine of theta is the reciprocal, so that should be plus or minus 3/5. All right, and then now this is where knowing theta, what quadrant theta is in, is going to come in handy to tell me if I should do plus or minus. So if you remember, all students take classes or take calculus, in first quadrant, every trig function is positive. So that means I'm going to take my positive one. So cosine of theta is equal to 3/5. All right, and that is my final answer. Okay, let me go ahead and I'm going to move down to number 3. I'm going to save the even ones for you guys to practice with. All right, so number 3, find the exact value of the expression. This time I have a theta in quadrant 2 between 90 and 180. And I have, if cosine of theta is equal to -7/8, I want to find secant of theta. Oh, well that's nice. Those are reciprocals of each other. So secant of theta is equal to -8/7. And I don't really need to worry about the plus or minus, since those are just reciprocals of each other. If cosine's negative, secant's going to be -2. All right, let's jump down to number 5. All right, so number 5, this time we have a theta between 180 and 270. So that tells me I am in quadrant 3. And this time they have cosecant of theta is equal to -2, and cotangent of theta is what I want to find. All right, so if you look through your Pythagorean identities, the third one has both of those. So let's go ahead and let's set that up. And I have 1 plus cotangent square of theta is equal to the cosecant square. So cosecant of theta is -2, so I'm going to square that. And solving for cotangent square, that gets me 5. Square root both sides, and I get cotangent of theta is equal to plus or minus rad 5. Okay. Oh, I'm sorry, 3. Oops. Okay. And so now I need to check what sign I should use. So in the third quadrant, tangent is positive. So if tangent's positive, its reciprocal cotangent should also be positive too. So I'm going to take the positive. So final answer would be cotangent is equal to positive rad 3. Okay, let's try our number 7. This time I have from 270 to 360. So that's going to be, theta is going to be in quadrant 4. And then I have cosine, and I want to find sine. So using my Pythagorean identity, the first one, I can set that up to be sine square theta plus cosine square theta, which is 6 over 7, is equal to 1. All right, so let's go ahead and solve for that. And so that's going to be 1 minus, this is 36 over 49, which gets me 13 over 49. All right, I'm going to square root both sides. And I get sine of theta is equal to plus or minus rad 13 over 7. Okay, so looking at where theta lives, we're in quadrant 4. And seems like cosine is the only, cosine and secant, it's reciprocal, will be positive, meaning sine must be negative. So I'm going to take the negative 1 of that. So final answer will be sine of theta is equal to negative rad 13 over 7. All right. So why don't you guys go ahead and try the even ones? And so pause the video, try the even ones, and once you're ready, unpause, and then you can check your answers with mine. All right, here are your answers for the evens. Number 2, answer I got was tangent of theta is equal to 3 rad 10 over 20. All right, if you need to pause the video to see my work, there it is. Number 4, answer I got was cotangent of theta is equal to negative rad 119 over 5. Number 6, I have tangent of theta is equal to 5 over 12. And lastly, number 8, I have sine of theta is equal to negative 4 over 9. All right, and that is it for your Pythagorean identities. Mr. P will do the back side for your next video lesson.